This is AQA GCSE Dual Award Science. It's a chemistry topic. It's also in the triple science, and we're on chemical calculations. This is part 3, where we're going to look at limiting reagents and using masses to balance equations. I'm going to recommend, as always, that you try the questions for yourself, pausing the video as you go, and then you're going to get to see how you are progressing with it for yourself. So we're going to balance equations, giving the masses of reactants and products, and know what the limiting reagent is. Got a hint sheet here which takes you through a question on masses to balanced equations, and we have an example here as well. You're welcome to pause that and try it, but I'm going to do this in a slightly different format when I go through the examples. So if we take a look at this question, potassium nitrate decomposes on heating to give potassium nitrite and oxygen. I'm actually going to use a table very similar to what we saw in the reacting masses questions in the previous video. Similar, but there are key differences. If I take the 3 substances that I'm interested in, KNO3 goes on to become KNO2 and O2. So in reacting masses, we would only ever have 2 columns, but here we have a column for everything. But I am now going to add in the M, MR, N, and ratio. And I can now start to put the masses in and work through. So I was told 4.04 of KNO3, I was told 3.4 grams of KNO2. So by using the law of conservation of mass, that means 0.64 grams of oxygen. I can now go through and work out the MRs. The MRs are 101, 85 and 32 respectively. And if I do a mole calculation for each of those, they now come to 0.04, 0.04 and 0.02. That's a 2 to 2 to 1 ratio. And that means that the equation is 2 KNO3 goes on to 2 KNO2 and 1 O2. Another example for you to try here. So lithium reacting with water to make lithium hydroxide and hydrogen. Following the equation through, these two make these two. I've built my table, I put my masses in. I need to calculate the mass of hydrogen by using the law of conservation of mass. 90 plus 35 is 125, so 120, I need 5 grams of hydrogen. I find the atomic or molecular masses. And from there I can work out the number of moles, 5, 5, 5 and 2.5. Divide all of those by the smallest and I get 2 to 2 to 2 to 1. So my equation is 2Li plus 2H2O goes to 2LiOH plus H2. Another example. And on here I've got my butane, my oxygen, my carbon dioxide and my water. I can put my different rows in to work through. These are the masses that I was given, so I need to work out the mass of oxygen. Law of conservation of mass brings me to 1040. My mass of reactants now equals my mass of products. I find my MRs, I put those in, and I use those to calculate my number of moles. 5, 32.5, 20 and 25. Let's now divide all of those by the smallest and I get 1 to 6.5 to 4 to 5. And that gives me my balancing for the equation. C4H10 plus 6.5 O2 goes to 4 CO2 and 5 H2O. Moving on to a second calculation type now, limiting reagents. Again, have a read through this, pause it. Here's a worked example. Here's another worked example. And with that in mind, have a go at these questions. So if I'm reacting lithium with water and I've got these masses, 28 grams of lithium, 36 grams of water, which one is the limiting reagent? Which one is going to run out first? Well, let's work out first of all for lithium, 28 grams, mass number of 7, that means I've got 4 moles. And if I do the same with water, you can see that I've got 2 moles, 36 over 18. Now I can see from the mole ratio, 2 moles of lithium react with 2 moles of water. On a 2 to 2 ratio or a 1 to 1 ratio, the lithium is therefore in excess. So the water is the limiting reagent. Another example for you. And once again, we go through, we do our mole calculations, 0.5 moles of sulfuric acid. I've got 2 moles of sodium hydroxide. On a 1:2 ratio, 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. So 0.5 would react with 1 mole of sodium hydroxide. That means the NaOH is in excess, and the sulfuric acid is the limiting reagent. It will run out first. Next example. Again, let's work through. I find that I've got 0.1 moles of calcium. I've got 0.2 moles of chlorine. Now, this is a 1:1 ratio, which means that 0.1 moles of calcium will react with 0.1 moles of chlorine. That means there's 0.1 moles of chlorine left. It's in excess. So the calcium is the limiting reagent. Final question. And once again, magnesium sulfate, let's work out. I have 0.1 moles. In my sodium, I've got 0.8 moles. Now 0.1 of MgSO4 would react with 0.2 of sodium. That means there's 0.6 of the sodium unreacted. That means it's in excess, and that means magnesium sulfate is the limiting reagent. That takes us to the end of this video. Thank you for listening, and goodbye.